ZGC is a garbage collector that, in the trade-off between footprint and pause time.
Hey Java developers! So as you saw in the intro, Nikolai and I originally talked about me covering Generational ZGC in this episode of Inside Java Newscast. But then Nikolai decided to preempt me and still cover ZGC in the previous episode of Inside Java Newscast. Well, I'm still going to cover ZGC anyways, but we're going to go into a bit more depth and how you can help. So to quickly cover where we currently are with ZGC, ZGC was originally released back in JDK 11. ZGC was designed to fill a then vacant niche among OpenJDK GCs of a GC with a very low pause times or latency. So let me back up a little bit. Generally speaking, when GCs are developed, there is a triangle of concerns, with each point of the triangle representing memory footprint, throughput, and latency. And as a triangle implies, focusing on one area does come at a little bit of cost to the other areas. Okay, let's quickly go to the qualification camera. Okay, when putting together this video, our GC folks, they actually described it more as a tetrahedron, with the other point being scale. And really, a lot of these trade-offs become more nuanced depending upon system architecture and usage. So, planning on doing a video that's more devoted to garbage collection, and at which point can really kind of dive into depth on these nuances, but for now, we'll just kind of stick with the triangle. So to jump forward a few releases, in JDK 15, ZGC moved from an experimental feature to a production feature. And then to jump forward a few more releases, ZGC is now in JDK 15 having max pause times of around 250 microseconds and your typical pause times measured in the tens of microseconds. This stands in contrast to other garbage collectors, which typically have pause times measured in milliseconds to even seconds. But as mentioned earlier with the triangle, this does come at a bit of a trade-off when it comes to throughput and memory footprint. Compared to G1GC, ZGC has about 10% less throughput and a bit larger memory footprint. So we are all caught up with ZGC. What does the future hold? Well, hopefully some improvements for memory management and maybe throughput. So currently, ZGC is a single generation garbage collector. What this means is it scans the entire heap for objects that are no longer in use. This is rather inefficient for CPU cycles and also when it comes to memory management. So the hope is to move ZGC to a multi-generational garbage collector like G1GC or Parallel GC. What this will allow ZGC to take advantage of is the weak generation hypothesis, which posits that most Java objects are short-lived. What this means is that when an object is first created, it is put into a young region, and this region is where ZGC will scan most often for dead objects. If an object survives enough of these garbage collection cycles, it will move to an old region that is scanned less frequently. This will allow ZGC to more efficiently use CPU cycles, scanning a region of the heap that is more likely to contain dead objects, and then would, as a result, also to be more memory efficient. In lab testing with Apache Cassandra, we saw about a 75% reduction in heap usage, and that's where you, the viewer, come in. We don't want you to take our word for it on these performance metrics. Really, we don't. Back in October, the ZGC team started publishing builds of Generational ZGC based on the early access of JDK 20. The ZGC team has done their internal testing and is now looking to hear for broader feedback. So if you're capable and willing, we at the Java Platform Group are asking you to try out these builds and to give us your feedback on them. Now, before you do that, there are a few things to consider, and here are a few key points. 1. Along with running tests and workloads against the Generational ZGC build, also be sure to run these tests and as similar workloads as possible against the most recent JDK 20 early access builds. This can help establish a proper baseline for performance. 2. As I mentioned earlier in this video, ZGC was designed with a goal of minimizing pause times. It isn't a straight upgrade over other garbage collectors like G1GC. So while we would be happy to hear about comparative performance between G1GC and ZGC, it's an apples to oranges comparison. 3. Also, if you're coming from another garbage collector like G1GC, ZGC will likely use more memory, so consider setting soft max heap size. This will hint to the garbage collector to try to keep under this heap size, but still allow it to expand if necessary to max heap size. 4. When running tests and workloads against Generational ZGC, be sure to enable VM logging. If you're running into issues, consider increasing logging levels to debug. 5. Areas of particular interest would be allocation stalls and significant throughput reductions, so definitely be on the lookout for those, but again, we are looking to hear any and all feedback. Okay, I think that's it. Oh right, so where do you get these Generational ZGC builds? Well, go to jdk.java.net/genzgc. And for the JDK Early Access builds, jdkjava.net/20. Remember that you will need to explicitly enable ZGC, and that can be done with +use ZGC. For Generational ZGC builds, Generational ZGC is automatically enabled, mostly because that's the only version of ZGC available on those builds. To give your feedback, consider posting it to the dev ZGC mailing list, link in the description. Also, if you have questions, post them as a comment to this video, or you can also reach out to me at Billy Crandall on Twitter, if Twitter is still around by the time this video is posted. Alright, that's it for this episode of the Inside Java Newscast. Jose will be hosting the next Inside Java Newscast. If you like this video, share with your friends. If you don't like this video, share it with your enemies. Alright, until next time, happy coding!